In the Normandy hedgerows, a German rifleman could be the better shot and still lose the exchange. The reason was not courage. It was not eyesight. It was not even accuracy. It was the fraction of a second when his firing hand had to leave the trigger, lift the bolt, pull it back, drive it forward, and lock it again. Across the hedge, an American carrying an M1 Garand did not have to make that motion. His rifle made it for him. That mechanical difference did not make an American soldier invincible. It did not erase training, terrain, machine guns, artillery, leadership, or fear. Normandy proved that nothing could do that, but it changed something basic inside a firefight. It shortened the distance between one aimed shot and the next, and the United States had managed to put that advantage into ordinary infantry hands on a scale no other major army matched at the beginning of the war. The strange part was that the man behind the rifle was not a famous general, a combat hero, or a weapons tycoon. John Cantius Garand was a toolmaker, and the decisive question he helped answer was not simply how to build a rifle that could fire again without a soldier working a bolt. It was how to build millions of them. Before the M1, the world's infantry armies had good reasons for trusting the bolt-action rifle. Germany had the Karabiner 98K. Britain had the Lee Enfield. The Soviet Union had the Mosin Nagant. Japan had the Arisaka. These were rugged military weapons built around a familiar cycle. Fire, unlock, extract, reload, lock, fire again. A trained rifleman could work that cycle quickly. A very good one could make it look effortless. But the motion was still there. Every shot created a small interruption in the weapon's ability to fire again. That did not automatically make a bolt-action army weak. German infantry doctrine, for example, placed enormous importance on the squad machine gun. The MG-34 and later MG-42 supplied much of the squad's sustained fire, while riflemen supported, protected, and fed that weapon. The American system developed differently. Its squad still depended on automatic weapons, artillery, mortars, radios, transport, and the rest of a much larger combined arms machine. But the individual U.S. rifleman carried something unusual as his standard rifle. A self-loading weapon chambered for the full-power .30-06 cartridge. Pull the trigger, the rifle fired. Gas from that shot helped cycle the action, eject the spent case, chamber the next round, and cock the rifle again. The soldier still had to aim. He still had to control recoil. He still had to conserve ammunition. He still had to survive long enough to fire again. What he did not have to do was take his firing hand away and work a bolt between every shot. That distinction sounds small when described on a drawing board. Under fire, small intervals become opportunities. John Garand had spent years thinking about intervals, tolerances, and moving metal. He was born in Quebec in 1888 and came to the United States as a boy. He left formal schooling early and learned his real profession around machinery. By 1919, he was working at Springfield Armory in Massachusetts, where the U.S. government employed him as a designer. The problem before him had defeated or disappointed generations of inventors. A military self-loading rifle had to do several difficult things at once. It had to withstand a powerful service cartridge. It had to keep working when soldiers exposed it to dirt, rain, dust, rough handling, and imperfect maintenance. It had to be simple enough to teach. It had to be accurate enough for infantry use. It had to avoid becoming so heavy or complicated that the theoretical advantage disappeared in the field. And then came the requirement that separated an interesting prototype from an army rifle. It had to be manufacturable. That requirement mattered because self-loading rifles were not a fantasy by the 1930s. Designers in several countries had already explored ways to use recoil or propellant gas to cycle a rifle automatically. The hard part was turning the idea into a standard service weapon that an army could trust, teach, repair, and afford in enormous numbers. Military skepticism was not irrational. A more complicated action created more surfaces, springs, and moving parts that had to survive field use. A rifle that made rapid follow-up fire easier could also tempt frightened or inexperienced soldiers to burn ammunition faster than supply could replace it. And a weapon that worked beautifully in a test environment could become a liability if dirt, heat, fouling, poor maintenance, or manufacturing variation pushed it outside its tolerances. So the argument was never simply old men refusing to accept a new invention. The question was whether the advantages of self-loading fire could survive contact with mass armies and mass production. Garand's answer had to satisfy both the rifle range and the factory floor. Not once. Not 100 times. Again and again, with parts produced to controlled dimensions, inspected, fitted, replaced, and sent into a supply system that might stretch across an ocean. Garand's background as a toolmaker mattered here. The weapon was not only a firing mechanism, it was an industrial object. In 1936, the U.S. Army adopted his design as the U.S. rifle, caliber .30 M1. It used an 8-round en bloc clip loaded from the top. After the final round, the empty clip was ejected with the metallic sound that would become inseparable from the rifle's legend. At first, that sound meant almost nothing outside the rifle range. The deeper meaning emerged only when war demanded numbers. The United States did not merely approve the M1 and reserve it for specialists. It committed to producing the rifle at enormous scale. Springfield Armory and Winchester built millions during the war years, while a vast industrial system supplied barrels, stocks, springs, clips, gauges, ammunition, replacement parts, packing crates, rail transport, ships, depots, and repair capacity. That scale changed the meaning of the design. A prototype can be tuned by the people who created it. A service rifle cannot depend on that kind of attention. One rifle might leave Massachusetts, cross the Atlantic, pass through a replacement depot, reach a unit after weeks of movement, and then be used by a soldier who had never met anyone involved in making it. If a small part wore out, the repair system needed a replacement that fit. If a rifle was lost, another had to arrive. If a recruit was trained in one camp and issued another rifle overseas, the controls and loading cycle had to remain familiar. Standardization turned the M1 from an inventor's achievement into a repeatable military capability. It also created a burden. 8-round clips and .30-06 ammunition had to move forward continuously. The faster a unit could fire, the faster it could consume what trucks, ships, depots, and men had carried to it. The rifle's advantage, therefore, depended on a second machine behind the first one, the supply system. This is where the story stops being only about a clever rifle. A self-loading weapon consumes ammunition faster when soldiers use its advantage. Faster follow-up shots mean more cartridges must reach the front. Clips must be available, parts must be standardized, damaged rifles must be repaired or replaced. Training must teach men when rapid fire is useful and when it is waste. The M1 therefore carried a hidden requirement inside its receiver. A nation that issued it widely had to feed it widely. America could. That did not mean every American infantryman fired 4 times faster than every German rifleman, or that rate of fire alone decided combat. Real firing rates depended on visibility, cover, ammunition, discipline, range, fatigue, and the tactical situation. A German squad with a functioning machine gun could generate devastating fire. An American squad caught in open ground could be destroyed before its rifles mattered. But when an individual rifleman needed a second aimed shot quickly, the M1 removed a mechanical interruption his bolt-action opponent still had to perform. There is an important distinction here. The M1 did not replace the squad machine gun, and it did not turn every rifleman into a machine gunner. The weapon was semi-automatic. One trigger pull for one shot. What changed was the baseline. Rapid aimed follow-up fire was no longer restricted to a specialist weapon or to the speed with which a rifleman could manipulate a bolt. It became part of the standard rifleman's normal equipment. That widened the number of places from which useful fire could come. If a squad's automatic weapon was masked, moving, empty, or focused elsewhere, the rest of the American riflemen still carried self-loading rifles. The effect was not infinite fire. It was a more distributed ability to answer quickly. That advantage became especially meaningful in broken terrain. Normandy's bocage country was a maze of sunken lanes, earthen banks, dense hedges, tiny fields, blind corners, and short sight lines. Units could be close without seeing one another clearly. Firefights could begin suddenly, and at ranges far shorter than the long-distance ideal associated with traditional rifle marksmanship. In that environment, the ability to fire, correct, and fire again without changing grip could matter immediately. Imagine the exchange without inventing a particular soldier. A German rifleman fires from a hedge line. He operates the bolt. An American fires back with an M1. The first American shot may miss. The second may miss too. Accuracy still matters, but the American can attempt that correction without pausing for the same manual reload cycle. The advantage is not that machinery abolishes skill. It is that machinery reduces the penalty for needing another shot. That was one reason the M1 impressed American commanders. General George S. Patton later called it, in his opinion, the greatest battle implement ever devised. The praise was dramatic, but the rifle's real importance is easier to see in less dramatic terms. It redistributed firepower downward. Instead of concentrating rapid fire only in specialized automatic weapons, the U.S. infantry system gave the ordinary rifleman a weapon capable of quick semi-automatic follow-up shots as his normal rifle. Germany recognized the problem, but recognition and mass issue were not the same thing. German engineers developed self-loading rifles, including the Gewehr 41 and the later Gewehr 43. Late in the war, German forces also fielded the Sturmgewehr 44, a weapon whose concept pointed toward the post-war assault rifle. Those developments showed that German designers were not blind to the changing infantry battlefield. The limitation was timing, production, and scale. By the time the improved German self-loading rifles appeared in significant wartime use, the United States had already committed years of industrial effort to the M1 system. Germany could introduce new weapons, but wartime pressure, competing priorities, material shortages, bombing, and a deteriorating strategic position made mass replacement increasingly difficult. A design can arrive before an army is able to reorganize itself around it. The M1 had arrived earlier, and timing matters in war because a new weapon is never only a weapon. It needs training manuals, production tooling, inspection standards, spare parts, ammunition allocation, maintenance knowledge, and enough time for units to absorb it. A late design can be technically impressive and still fail to reshape the army that receives it. The German Gewehr 43 and Sturmgewehr 44 demonstrated that German engineers could produce capable modern small arms. But by the time those weapons appeared, Germany was fighting under conditions very different from the United States. Shrinking access to resources, mounting losses, competing equipment demands, transportation disruption, and increasing pressure on its industrial base. The issue was no longer whether a better rifle could be designed. It was whether a new system could be produced and distributed fast enough to matter at the scale of the war. There was also a psychological dimension, though it is easy to exaggerate. The Garand's empty clip made a distinctive ping. A famous wartime legend says enemy soldiers learned to listen for that sound because it signaled an empty rifle, and that American soldiers sometimes tried to exploit the expectation by making a false ping with an empty clip. The story has been repeated for decades, but its practical importance in the noise of combat is disputed. That uncertainty is part of the lesson. The ping became famous because it gave people a sound for something real. The M1 had changed the rhythm they associated with an infantry rifle. Fire no longer had to be followed by the visible hand movement of a bolt cycle. Another sign of the rifle's value came from capture and reuse. The German military cataloged foreign weapons it encountered and pressed usable captured equipment into service when circumstances allowed. M1 rifles taken from American forces were among the captured small arms Germans could use. That did not mean captured Garands transformed German units. Ammunition, clips, spare parts, and familiarity all limited the usefulness of enemy equipment. But it revealed the central irony. The rifle was most powerful not as an isolated object in someone's hands, but as part of the system behind it. A captured M1 gave a soldier a semi-automatic rifle. The American industrial and logistical network gave an army millions of rifles, replacement rifles, ammunition, clips, spare parts, trained armorers, and a steady path from factory floor to front line. That difference cannot be picked up from a dead soldier. It has to be built. And building it required more than Garand. It required machinists who held tolerances, inspectors who rejected bad parts, workers who shaped stocks, foundries and steel mills, ammunition plants, railroads, ports, ships, depots, and men in supply units who rarely appeared in heroic photographs. This is why calling the M1 a miracle weapon misses the more important story. The rifle worked because it was not a miracle. It was standardized, it was reproducible. It could be inspected, packed, shipped, repaired, and replaced. Its battlefield advantage was inseparable from boring industrial repetition. John Garand stood at the center of the design, but he did not become rich from it. As a government employee, he assigned the relevant patent rights to the United States and did not collect a royalty on every rifle produced. A proposal was later made in Congress to grant him a substantial award in recognition of his contribution, but the payment did not become law. He retired from Springfield Armory on a government pension and died in 1974. That ending can sound unfair, and perhaps it was. But it also fits the character of the weapon he created. The M1 became important because no single person had to be extraordinary for the system to work. Not the factory worker making one part, not the inspector checking it, not the recruit receiving the finished rifle. The design took specialized knowledge at the beginning and converted it into repeatable capability at the end. That is the deeper contrast between the bolt-action marksman and the American rifleman. It was never simply expert versus amateur. It was a contest between two different ways of placing firepower inside an infantry formation. One system still asked the individual rifleman to perform the reload cycle by hand after every shot, while relying heavily on the squad machine gun for concentrated automatic fire. The other gave its standard rifleman a self-loading weapon, and then built the industrial and logistical machinery required to keep that weapon fed. Neither system removed fear, neither removed casualties, neither made tactics unnecessary. But one of them turned a fraction of a second into something that could be manufactured by the million. By 1944, that fraction of a second was crossing beaches, entering hedgerows, moving through ruined towns, and appearing in the hands of men who had not spent years mastering a bolt action. Their advantage was not that the rifle made them better men. It was that the system behind the rifle had already performed part of the work for them. Somewhere at the end of 8 rounds, the clip left the receiver.